Hello everyone. In this video we're going to investigate whether areas scale the same as linear measurements. You may have already determined that they don't, otherwise this video would be over already, but let's take a closer look anyway. So here we have a rectangle with a width of 12 and a length of 4. In order to determine the area, we do area equals length times width, which is 4 times 12, so we get an answer of 48 centimeters squared. And now we need to complete the table below. So if we have a scale factor of 1, the length doesn't change, that's still 4. The width doesn't change either, that's still 12. The area is still 48. The original area was 48. And if we do 48 divided by 48, that gives us 1. The scale factor is 1. 1 times itself is 1. And if we multiply the square of the scale factor by the original area, we still get 48. If we have a scale factor of 2, the length becomes 8. The width becomes 24. The new area is 8 times 24, which is 192. The original area is still 48. If we do the new area divided by the original area, we do 192 divided by 48, and new divided by original gives us 4. In order to determine the square of the scale factor, we do 2 times itself, which is 4. And if we do scale factor squared times the original area, which is 48, we do 4 times 48, and we get a result of 192. I would encourage you to do these next 2 rows on your own. Maybe take a moment and pause the video, and you can check your answer in 1 second. So here's the result of those 2 rows, and we'll do the next row together. So if we multiply the length of 4 by a scale factor of 1/2, we get a new length of 2. And if we multiply the width of 12 by 1/2, we get a new width of 6. So the new area would be 2 times 6, which is 12. The original area is still 48. If we do the new divided by the original area, we get 1 over 4, or 0.25. The scale factor squared, 1/2 times itself, is also 1/4, or 0.25. And the scale factor squared, which is 1/4, multiplied by the original area, which is 48, is equivalent to doing 48 divided by 4, which gives us an answer of 12. And I would encourage you to pick up that last row on your own. You can pause the video and check your answer in 1 second. So there's the result of the last row. Next we need to compare the values in this column versus this column, and you should notice that they're the same. Moving on to number 2, we have a circle with a radius of 4, and the area is given by pi times r squared. So the area of this particular circle is pi times 4 squared. 4 squared is 16, and we go 16 times pi, which gives us an area of 50.3 centimeters squared. And now we need to complete the table below. So a scale factor of 1 would leave the radius unchanged. The area would be the same as it was originally. The original area was 50.3. The new area divided by the original area would be 1. The scale factor squared would be 1, and 1 times the original area is still 50.3. So in the next row, a scale factor of 2 would change the radius to 8, and the new area would be 8 squared times pi. 8 squared is 64, times pi gives us 201.06. The original area is 50.3, and if we do 201.06 divided by 50.3, we get 4. And the scale factor squared, 2 times 2, is 4, and 4 times the original area of 50.3 is 201.06. I would encourage you to do the next 2 rows on your own. You can pause the video and check your answers in 1 second. So there's the results of the next 2 rows. I've rounded the areas to the nearest tenth. My calculator displays more digits, but if I leave these values unrounded and do a calculation, for example, like 452.4 divided by 50.3, each unrounded, I get an exact value of 9 for this column. We'll do this next row together. A scale factor of 1/2 would change the radius to 2, and the new area would be 2 squared times pi, so basically 4 pi, which is approximately 12.6. The original area is approximately 50.3, and if we do the full unrounded value of 12.6 and the full unrounded value of 50.3, one divided by the other gives us 1/4. The scale factor squared is 1/2 squared, so 1/2 times 1/2 is 1/4, and the scale factor squared times the original area of 50.3 gives us 12.6 approximately. I would encourage you to do the last row on your own, so you can pause the video right now and check your answer in 1 second. So here's the result of the last row. And if we compare the values in the column labeled new area to the values in the column labeled scale factor squared times original area, you should notice that they're the same. So it looks like area scales differently than length. You can scale a length by either multiplying or dividing by the scale factor, and you scale an area by either multiplying or dividing by the scale factor squared. So moving on to question number 3, we're looking to determine the area of the trapezoid shown. We have a formula supplied here. 18 is B, 10 is A, and we need a perpendicular height, and it looks like that hasn't been supplied yet, so we need to use trigonometry to figure it out. So in this right angle triangle, we have the hypotenuse, we need the opposite, and we have a reference angle of 40 degrees. So we need to use sine. So sine of 40 is equal to opposite, which I've labeled h, divided by hypotenuse, which is 7. So that means the opposite side length is given by 7 times sine of 40. Make sure you're in degree mode. We get a height of 4.49. So now we can use our formula here. Just plug in what you know. The area is 1/2 times the height, which we just found, times a plus b. A is 10 and b is 18. So we can multiply 0.5 by 4.49 by 28, and we get a result of 62.99 and some other digits, which is approximately equal to 63 centimeters squared. If a scale factor of 3 is used to draw a new trapezoid, what would the new area be? So based on the lesson we learned with the rectangle and the circle from earlier, the area of a shape scales like the scale factor squared. So if the scale factor is 3, we would determine the new area by multiplying the old area by 3 squared, which is 9, and we would get a result of 567 centimeters squared. In question number 4, we need to determine the area in square units of the picture below after all linear measurements are reduced 30% and enlarged 200%. So it would be helpful to determine the original area first. We have a trapezoid here and a half circle here. So the area of the original shape is given by the sum of the area of the half circle, which would be 1/2 times pi r squared, plus the area of the trapezoid with the formula 1/2 h times a plus b. Remember, the area of a full circle is given by pi r squared. And because we're doing a half circle in this example, we need to multiply by 1/2. So we have 1/2 times pi times 5 squared, which is 25, plus 1/2 times the height, which is 4, times a plus b. A is 10, that could be that length, and b is 20, so that would be this whole length. So the area of the half circle works out to be 39.26 and some other digits, and the area of the trapezoid works out to be 60, so the original area is 99.3 units squared. If all linear measurements are reduced by 30%, that means we have a new shape with linear measurements that are 0.7 times the original. So the scale factor for linear measurements would be 0.7. If we want to determine the new area after all linear measurements have been reduced 30%, we need to multiply the original area, 99.3, by 0.7 squared. So the new area would be 48.6 units squared. And if all linear measurements are enlarged 200%, so if there was an enlargement of 100%, an original radius of 5 would be increased to 10, because 100% of 5 is 5, and if we enlarge that 100%, we would go 5 plus 5. And if we enlarge the original radius of 5 by 200%, since 100% of 5 is 5, 200% of 5 is 10, so we would need to add 10 to the original 5. So a 200% increase would get us to a radius of 15, which amounts to multiplying our original radius by 3. So the scale factor if we're enlarging all linear measurements by 200% is 3. And the area will scale by 3 squared. So if we take our original area and multiply it by 3 squared, we get a new area of 893.4. In number 5, the area of the inside triangle is 4/9 the area of the outside triangle. If the length of the base of the inside triangle is 27 centimeters, then determine the length of the base of the outside triangle. So in order to get from the outside area to the inside area, we need to multiply by 4/9. And if we're scaling the area, this amounts to the scale factor squared. So the scale factor would be given by that square rooted. So if we square root 4 over 9, that gives us 2/3. So in order for us to get from a length on the outside to a length on the inside, we need to multiply by 2 over 3, which amounts to a reduction because 2 over 3 is 0.6 repeating, and that's between 0 and 1. So if we multiply by 0.6 to get from an outside length to an inside length, we need to divide by 0.6 to get from the inside to the outside. So if the base of the inside triangle is 27 centimeters, we need to multiply by 3 over 2. This scale factor would amount to an enlargement, which would be required to get to the outside triangle. So if we multiply 27 by 3 over 2, we get 40.5 centimeters. In question number 6, a quilt for a baby's crib has 18 triangles, each with an area of 120 centimeters squared. A matching quilt is to be made for the baby's older sister. If the design is exactly the same, but the total area of the new quilt is 3.456 meters squared, then determine the scale factor that can be applied to the dimensions of the baby quilt so that the older sister's quilt can be made. Based on the information given, we can quickly determine the area of the baby's blanket. So if we have 18 triangles, each at 120 centimeters squared, the total area of the baby's blanket is 18 times 120, which is 2,160 centimeters squared. So to solve this question, we need to do the baby blanket area times the scale factor squared to determine the sister's blanket area. There's a couple ways this calculation can go wrong. I'll walk you through them right now and see if you can spot the error on your own. So first we're going to go 2160 times scale factor squared equals 3.456. In order for me to determine the scale factor, I divide both sides of this equation by 2160. 2160 divided by itself is 1. This gives me 0.0016 on the right hand side of this equation. I need to square root both sides to get the scale factor, and I see the scale factor is 0.04. So this turns out to be wrong because the units of area on the left side of the equation are in centimeters squared, and the units of area on the right side of the equation are given in meters squared. So let's see if we can correct that. So again, I'll use 2160 for the area of the baby's blanket. Multiply that by the scale factor squared, and this time I'm going to be a little bit smarter. I know that 1 meter equals 100 centimeters, so I'm going to multiply 3.456 meters squared by 100 to get 345.6 centimeters squared. Again, I'm going to divide both sides by 2160. 2160 divided by itself on the left is 1, so we get scale factor squared equals 0.16. I need to square root both sides of this equation, and I get a scale factor of 0.4. So the error that happened here is I failed to convert the area of the larger blanket properly. In order for me to properly convert 3.456 meters squared into centimeters squared, I need to multiply by 100 twice. So you could think of it as 3.456 meters times meters, and if I multiply by 100 over 1, that converts only 1 meter. So these two would cancel, and I would be left with units of meters times centimeters. So I need to multiply by 100 again, and that cancels these 2 meters. And now I have centimeter times centimeter, which is centimeters squared. So that means 3.456 meters squared is equivalent to 34,560 centimeters squared. So the proper equation would be 2160 times scale factor squared equals 34,560. And now I have centimeters squared on this side and centimeters squared properly converted on this side as well. So now I can divide both sides of this equation by 2160. So that gives us the scale factor squared is equal to 16. And if we square root both sides of this equation, we get a scale factor of 4. So if we're looking to scale the area, we multiply by 16. But if we're looking to scale the linear measurements of the blankets, we need to multiply by 4. So here's some important formulas you'll need to know that can be found on page 475 of your textbook. I'll get you to do this question. That's it for me for today, and I'll see you next time.